f plus g of x. What do you think that means? You guys might be able to guess without me telling you. What do you think that means to do?
Square off and then get rid of the parentheses.
You just, hey, don't you just plug in stuff like
Oh, we just take care.
Yeah, all we do is add those two functions together. It's up in the directions. F of x is 3x minus 4. I'm just reading this from the directions. And g of x is x plus 1. So all we have to do, this is kind of easy. All we have to do is add these two functions together. Well, guess how we add this and this together? This is the name of the function, but this is actually what the function is. So how do we add these two together? Yeah, like terms. 3x plus x is 4x, and negative 4 plus 1 is negative 3. So that's it. 4x minus 3.
That's easy peasy.
Yeah. You just jinxed everybody.
No, because I have my fingers crossed.
Crossed your toes.
Yeah. There is one trick that we need to talk about, but that's kind of it. So number 3 is h minus g of x. So h of x is 2x squared minus x minus 3. Minus g of x is x plus 1. So here's one way you could write it. That's h of x, all that stuff, and g of x is the other one. So how do we subtract these two? What do I do with the 2x squared?
Deep down.
Nothing. What do I do with the minus x?
Wait, I'm just lost right now.
No, -2.
Right. Negative x minus x is negative 2x. All I did was I copied down h of x, which is this stuff, and g of x is this stuff.
So what is
Subtracting the two.
Is x always going to be x plus 1?
No, that's g of x.
Yeah, well, no. What?
From the directions. I got it from the directions.
It wasn't that.
It's just h minus g. We're subtracting the two functions.
I'm looking at that, but it doesn't say like a...
The directions up above in the dark. Anyway, we got a negative 3 right here and a minus 1, not a plus 1. So it's minus 4. You got to subtract all of this g of x stuff. So not just the x and the 1.
You have to split into 2 or no? You have to split into 2 if it's an x squared.
Split into 2. Oh, you mean factor it?
Yeah.
No. Factoring is only useful in certain situations, but it's not. Factoring is not simplifying. Yeah.
Are you kind of just like, is it kind of just like your cross multiplying or?
No, that's subtraction. You just did this minus that.
You just did it with minus 1.
H of x minus g of x. Minus. You can only add and subtract like terms. We subtracted the like terms. Number 5, what do you think fg of x means? Multiply. So f is 3x minus 4. And g was the x plus 1. So how would we multiply these two things? Foil. Because it's just these two times these two, right? So yeah, that's a FOIL problem. So first is 3x squared. Outside, 3x times 1. Inside, negative 4 times x. And last, negative 4 times 1. What else can I do?
Simplify that increase.
Yeah, the middle terms are like terms. Plus 3x minus 4x is negative 1x. Alright, let's see, that was number 5. There's only 7. Alright. What do you think 7 means? Divide, yeah. So f was 3x minus 4 divided by x plus 1. No, that doesn't divide very well. Okay, so doesn't really divide. All they did, they just left it like this. They did also write, you guys know what this means? This is the answer right here, but that divided by that doesn't work very well, so just left it alone. It's kind of like, what's 3 divided by 4? 3/4, right? So that's basically what they did. Why? Do you guys know why they wrote this?
You get charged in exclusion.
Okay, why can x not equal negative 1? Because it would make, it'd be like dividing by 0. Negative 1 plus 1 is 0. So that's not possible. So this is the answer except for x can't be negative 1. That's just a little qualifier. Number 9. Okay, this is new. I might need to write out everything just to show you. So f of x is 3x minus 4. G of x is x plus 1. Let me pause for a second, go back and look at number 6. 6 is 3x minus 4 times 2x squared minus x minus 3.
It's just the distributive property.
Yeah. You guys know how to multiply those two things together?
Foil.
Not really FOIL.
If you just-
This is 3 terms, so you can't really use FOIL. Yeah, you do 3x, it's like, yeah, super FOIL. 3x times all 3 of those, and minus 4 times all 3 of those.
Then you add the trifoil.
And then you add all the like terms. Like, so for example, the first term, 3x times 2x squared is 6x cubed. There's a lot. Should be 6 terms altogether. And then some of them should be like terms. And okay, now back to this. Alright, you see that little circle thing there? This is read as f of g of x. It can also be written like this. I actually kind of prefer this. I think the book uses this more. But these two things mean the same thing. It means, what it means is we're going to pick up everything that's g of x and put it into the f function. So we're going to take this function, the g, and put it into the f function. Stop doing that. Turd. All right. There we go. So we're going to put the g function into the f, the g function into the f. So this is the g function. How do I put it into the f function? Basically, you put it in the spot where the x is. So we're going to rewrite this function right here as 3, instead of 3 times x, 3 times this stuff. So 3 parentheses x plus 1 minus 4. You can simplify it a little bit, yes.
So 3x plus 3 minus 4.
Right. 3x plus 3. What's 3 minus 4?
1.
Negative 1, right? So yeah, it does simplify a little bit. I guess I'll copy the title again. Alright, you guys see how we did that? So we took this function on the right and plugged it into the one on the left, like this. Number 11, h of g of x. This one might be a mess. So, okay, I'll put it over here. H of x is like 2x squared minus x minus 3. And g of x is x plus 1. Okay, now what did we put into what on this one?
The g in the x place.
Okay, the g is going to go into the h function. So I'm going to pick this up. Yes, and replace x. Now notice x is in two spots on this one. So I'm going to have to put it there and there. So I'm going to rewrite kind of this one. 2 times, instead of x, we're going to put in the g from this. X plus 1 squared minus x plus 1 minus 3. Everybody see what I did? Yeah. Alright, substitution basically is what's happening. Can I simplify that? Yep. Great, so how do I simplify x plus 1 squared? Exponent comes before multiplication, right? Yeah, it's x plus 1 times x plus 1, like all of it. So it's x times x, x squared, x times 1, 1 times x, 1 times 1. Okay, that's all the FOIL stuff. Now what can I do? Multiply the 2.
At the same time, it also negative.
Now what?
The negative.
Subtract this thing over here, right?
Yep.
So can I do anything with 2x squared? No, there's no like terms with 2x squared, so it's by itself. But I have a 4x and a minus 1x, which makes 3x. Then I have a plus 2. What's this right here?
Negative 1
A minus 1,
plus 1. but
which
then
is
you have
1, and a minus 3.
So negative 2.
Right. 2 minus 1 minus 3, yeah, it's negative 2. That's all we can do. It's a lot of work on that one. Just making sure you guys had, at least had a good calculator. If you need help with the imaginary ones, you can borrow this one, or maybe if Archie gets done, you can borrow it, or Montana can let her borrow yours.
This one does it.
Yeah, that's a good
Yeah,
one.
this is one. Thank you.
All right, I think we're done with that page. 13. Okay, these are really short, so listen carefully because it'll be over in a few seconds. Up, these are kind of weird. I almost thought about skipping these, but up in the directions it says f equals -2, -1, 0, 1, 1, 2. You guys see where I'm looking? That basically means in the f function, when the x value is -2, when you plug in -2, -1 comes out. Negative 1's like the y value. When you plug in negative 2, negative 1 comes out. Or the next parentheses, when you plug in 0, 1's supposed to come out. When you plug in 1, 2 comes out. Okay, so it's just kind of a weird way of defining a function. Instead of, normally functions look like f of x equals 2x minus 1. So you just plug an x in and then work it out and figure out what.
So you have to see which one's right.
No. So on number 13, basically that means we're going to figure out what g of 1 is, and then whatever that is gets plugged into the f function. Okay, so what is g of 1? So you got to look at the directions. 2. When you plug 1 into the g function, you get 2. So now we're going to take that 2 and plug it into the f function.
So 3?
Right, and the f function 2 gives you a 3. You plug in 2 and 3 comes out. So the final answer is 3. So we plugged 1 into the g function using the directions. And when x is 1, the function is equal to 2. So 2 came out. Then we plugged in 2 into the f function. And on the f, when x is 2, 3 comes out. Okay, 15, you're supposed to add them together. So basically you figure out what f of 0 is and g of 0, and you add those together. So what is f of 0? 1.
Wait, how'd you
0,
go?
1.
Yeah, sorry.
And then what's g of 0?
2.
4.
So 5?
See where it says 0, 4?
Okay.
Yeah, so f of 0 plus g of 0 is 1 plus 4.
These are the easiest ones.
So it's 5. Number 17. Guess what that means? Multiply. So we're going to multiply whatever f of 2. Probably this is kind of what it means. What's f of 2 times what's g of 2? Okay, what's f of 2?
3.
3. What's g of 2?
0.
0. So what's 3 times 0?
0.
On 18, which one will we do first? The one on top or the one above?
Doesn't matter. It's f of 0 divided by g of 0.
Oh, right, yeah.
Okay, 19. I wonder if I want to do
No, we don't want to do this.
25 through 30 instead of 19 through 24. Might be better.
Yeah, let's do that.
Hold on, let me think.
It'd be better for our
Well-
students.
Well, no, I think for the first one, wouldn't that like to do the, all the factoring, the formulas?
Yeah, you do the
Would you have to do like
substitute.
Okay, we'll stick with the original game plan. It's kind of like the first 12, 19 through 24 is the A part is like the first 12. The B part, I'll explain it here in a second. So it says f plus h of x. So we got to simplify this. F of x is, where is it? Up at the top. 2x minus 1 plus x squared plus 3x minus 10. Alright, so we're going to add those two together. What's the rules when you're adding or subtracting? Like terms. Is there any like terms with x squared? No. How about the 2x? 2x plus 3x. Do the parentheses matter when you have a plus? No. So I don't really have to, but if there was a minus right here, that would matter because you have to subtract all of them. But if you have to add them all, like adding a negative 10 is just minusing 10. So negative 1 minus 10,
Negative 1.
negative 11. Okay, this is the answer to the A part. Alright.
We're gonna have to do A and B for every single one.
For the B, all they wanted you to do is they kind of chose a random x value, like of 3. They want us to show that plugging 3 in here, like f of x plus h of x, plugging in the 3 over here, is the same thing as plugging in 3 to our simplified function. Does that make sense? They want to show if we put 3 in on this side before they were simplified, like this was the f of x, this was h of x. If we plug in 3 here and here and add them together, that's the same thing as just plugging in 3 to our simplified function. Okay, I'll do this on the odds, I'm not going to make you do it on the evens. So on the evens you just do the A. So if I plug in 3 over here, that's 2 times 3 minus 1, 5. 3 squared is 9, plus 3 times 3 is 9, minus 10 is 8. 5 plus 8 is 13. And then if I plug in 3 over here, 9 plus 15, 24 minus 11 is 13. So that's what they wanted. Some shows like 13 equals 13. So anyways, that's it.
So should we just write 13?
Yeah, we'll just say that 13 equals 13. You guys see what they're saying? Plugging in into each function individually and adding them together gives you the same result as plugging it into our combined function. All right, 21. F times g of x. So 2x minus 1, x plus 5. So it's another FOIL problem. So first, outside 2x times 5. Inside, and last, negative 1 times 5. Simplify a little bit more. This will be our A answer. 10x minus 1x is 9x. So for the B, if I plug in the 3, 2 times 3 is 6, minus 1 is 5. 3 plus 5 is 8. So if I plug them in both functions individually, I get 5 and 8. 5 times 8 is 40. If I plug them in my simplified function, 3 squared 9 times 2 is 18. 9 times 3 is 27. 18 plus 27 is 45, minus 5 is 40. Suejo iga. H divided by x. H divided by g of x. Okay, dividing x squared plus 3x minus 10 divided by x plus 5. Well, does that simplify? Yeah, it does. Do you guys remember back when we did synthetic division and long division and all that stuff? There's kind of an easier way to do these. If it comes out nicely, top should factor. What's this factor to on the top? What multiplies into negative 10 that adds up to 3?
-2 and 5.
5 and minus 2. So guess what's going to happen here?
Can you simplify?
Yeah.
Just x minus 2.
Yeah. The products and the division, they cancel out. When you're multiplying and dividing the same value, they cancel out. So x plus 5's go away and you just get x minus 2. But the book probably put this. You know why they put this qualifier here? Right, even though it turns into x minus 2, negative 5 still doesn't actually work. So this is really the answer, but this is kind of the extra, I guess. Little side note, asterisk. Okay, we could have gotten that using synthetic division or long division. You guys remember synthetic division? Like you put negative 5 in the box and you put 1, 3, negative 10 across. You're probably rusty on it, aren't you? Add down, multiply up, all that stuff. This right here stands for 1x minus 2, which is what I got from factoring and canceling. You guys liked synthetic division at one point.
Yeah.
Most y'all. Oh, I forgot though. A little rusty. Alright, if I did the B, if I plugged in, this is A. If I plugged in 3 over here, this would be 9 plus 9, 18 minus 10 is 8. 3 plus 5 is 8. That comes out to 1. If I plug in 3 here, 3 minus 2 is 1. So it's like 1 equals 1. Works on both. The only thing that would not work is if I tried plugging in negative 5. Yeah.
Would you not have to do B on the rest of them?
You said what?
What?
Or you don't have to do B on the rest of them?
No, that's fine.